The problem we're going to be looking at on this video is the problem on the back of the Parabola worksheet involving the bridge. This is a bridge over the downtown canal. I took a picture of the bridge. I made up the dimensions, but I hope they'll be reasonable. The question asks, if the bridge shown in the picture is 30 feet wide at the surface of the water and 6 feet above the water at its highest point, so 30 feet across, 6 feet down, would a boat with a canopy that's 6 feet wide and 5 feet above the water be able to fit under the bridge? Would two such boats be able to go under the bridge side by side? Whenever you do a story problem, you can graph the figure involved wherever you want and pick a location that's most convenient and easy to work with. So I decided to pick the vertex to be at the origin in this grid. So I just arbitrarily picked that. Then I would need to go 6 feet down to the surface of the water, and since the bridge is 30 feet wide at the base, I would be going 15 in either direction, which makes this point right here have the coordinates 15, negative 6. Now that's going to be really helpful because now I just need to write an equation for this parabola so that I can use that equation then to help me answer the question. So the equation is going to be either in the form x squared equals 4py, or y squared is equal to 4px. Remember that 4p is just a coefficient. I could easily write that as x squared equals ay or y squared equals ax and just use a as my coefficient. Because this is opening downward and it opens in the direction of the unsquared variable, I can eliminate the y squared equation, use the x squared equation. Now I want to find what this number 4p equals, and I happen to know an x and a y from my 15 and my negative 6. So I'm going to put in 15 for x and negative 6 for y and solve for 4p. So 15 squared divided by negative 6 is equal to 4p. And that turns out to be negative 37.5 is equal to 4p. So my equation of my parabola, and I hope I haven't been saying ellipse, I think I may have, is x squared is equal to negative 37.5y, or x squared divided by negative 37.5 equals y. Now to use that equation to answer the question that I've been asked, I have to notice, I have to draw in my boat. So this boat is 6 wide and 5 tall based on the description in the wording of the problem. So if I have the boat go straight under the middle of the bridge, which seems to be the most logical place to send it, this corner would be at the point 3, negative 1. So negative 1 down from the road, the surface at the top of the bridge, and 3 from the center. Now what I want to know is, does that point hit the bridge or not? So I need to know when the bridge is at 3 in the x direction, what is the y value of the bridge? Well, I happen to have a nifty equation that will help me figure that out. So I'm going to put 3 in for x and say 3 squared over negative 37.5 is equal to y. And it turns out then that y is equal to, let's see, I gotta find my value here. Where is my value? I don't think I have the answer for that particular one. I think it's, I think if I solve this, it's 9 over negative 37.5 is equal to y, and that value turns out to be approximately 1/4, negative 1/4, okay? And you can figure out exactly what that is. Well, the value, as long as y is less than negative 1, then the bridge is going to be above the boat. So the bridge is higher than the boat, so the boat does go, the boat is 1 foot down. The bridge is only, let me get rid of that for a second, about 1/4 foot down, so the boat fits under the bridge. Now I'm going to leave it to you to do the problem where there are two boats side by side, and you can assume there is no space in between them.